So thank you, everybody, and welcome to Inspiration Exchange today. My name is Fergus Imrie, and I'm a postdoc in the Schaar Lab, for those that don't know me, and I'm delighted to welcome you to today's session on synthetic data. And welcome to our first session in 2023. So in today's session, we're going to consist of two parts. In the first, we're going to discuss synthetic data for a bit, and in particular, we're going to introduce our lab's new package, SinCity. And in the second half of the session, we're going to move to a roundtable and Q&A discussion. And I'm delighted to announce that we've been joined by 6 fantastic panelists from a diverse range of industries, from regulators through pharmaceuticals and healthcare, and finance and consulting as well. So I'll introduce all of our speakers later on in the session, but that's just a sneak preview of what's to come. Without any further ado, however, I'm going to invite Mihaela to give a brief introduction to the session about synthetic data.
Thank you very much, Fergus.
Share when ready.
Thank you very much. I will not share, so I will just want to welcome everyone to this session today. Thank you very much to our panelists for joining us and everyone else. I'm absolutely delighted to have this session on synthetic data today because this has been a very long journey for us as a research lab. We have started really, I would dare say, as the pioneers of this topic of synthetic data 7 years ago. And at the beginning of the journey, it was quite difficult to convince people that they need synthetic data. Now, the success of this particular session and more generally of synthetic data, as shown in NeoRIPS workshops that we have held in the past years, as well as tutorials, have shown that synthetic data is a reality. And why I'm especially excited about this particular session is that while a lot of synthetic data has originally been envisioned as a tool for creating copies of the original data, but with privacy, let's say, guarantees. As you are going to see today, we have nowadays moved beyond that particular copies. If we are not just making copies of original data, we are able to create better data than the original while using synthetic data, and Zhaozhi will show that to you. I'm also finally very excited because Zhaozhi and Bogdan have worked extremely hard over the last half a year to make this wonderful open source package available to everyone to use, thereby hopefully democratizing synthetic data for a wide variety of audiences. Without further ado, Zhaozhi, the floor is yours.
Great. Now I think everyone can see my screen. And welcome again, everyone, and thanks, Mihaela, for the introduction. And I'm really excited to present to you SinCity, which is a open source software that our lab has recently released. And the goal of this software is to facilitate and democratize the usage of innovative use cases of synthetic data. And as we all know, that availability of high quality data is of paramount importance in machine learning research. And as one example, the ImageNet dataset has led to a lot of great progress in computer vision and image. And more recently, large language models like ChatGPT are based on internet scale text and conversation data. However, accessing high quality data is not as easy to do in many other domains, for example, healthcare and finance. And typically, people will encounter barriers or low quality data or various issues of data issues when trying to build analytics. And the research community over the years has found synthetic data as a potential solution to fix various issues with the real data. And this includes, first of all, the real data being private and sensitive, and we can potentially create privacy-preserving synthetic data and share them outside the organization onto a broader audience. The real data may also contain pre-existing bias. For example, it may underrepresent certain ethnicity group, and synthetic data can be created to augment and debias the real data. And very often, the real data may come up with very sample size and is costly or time-consuming to acquire real data. So in that case, it might also be possible to augment the real data with synthetic data, so to increase the overall effective sample size. And finally, the real data may be collected from multiple domains, and synthetic data has shown some early promise in also facilitating transfer learning and domain adaptation across multiple environments. And as we see here, synthetic data is actually a unified way or a single approach to fix many data issues and empower the practitioners, because it is very much agnostic to any analytical models being used. So the standard statistical model as well as more advanced machine learning models can all be applied on top of a synthetic data set. And this is part of the reason that synthetic data has been a very promising topic, and it has attracted an exciting community of both researchers and practitioners. But in order to move forward and really make synthetic data agenda a reality, we want to build better software so that people can get access to this cutting edge research. And this is one of the motivation of SinCity library. And it's designed to facilitate a broad range of use cases and data modalities and provide a single access point to many cutting edge methods. So before diving into the detail of SinCity, I want to start by briefly introducing the general workflow of synthetic data. As shown in this diagram, the general workflow usually involves 4 steps. And SinCity has also 3 different modules to facilitate that. Firstly, the real original data is loaded using some data loader into the library. And then a generative model that fits for the specific purpose is selected and trained. And then after training, the generator can be used to generate synthetic data sets. And finally, the synthetic data sets should be evaluated carefully before it is used in downstream analytical tasks or released to other domains. So here, the SinCity contains 3 main modules: data loader, plugin, and metric module to facilitate this whole process. It also contains a benchmark module, which is a wrapper around the whole process, and it can be used to automatically test and benchmark different generative models in a click of a button. So it's really, that one is really for benchmarking and model selection. So now let's talk about data loader and what type of data modality SinCity is able to handle. So currently, SinCity focuses on tabular data modality because it's widely used in different industries. However, even if we just look at tabular data, there are also a wide range of data modalities. First of all, the tabular data can be in a single data set format where we only have 1 table, or it can be a composite data set which consists of multiple tables linked together. And furthermore, even in the single data set setting, the data modality can be further described by observation pattern and feature type. And by observation pattern, I mean how the data is observed over time. So for instance, we have static data where the records does not have any temporal ordering or dependency. We also have regular time series where observations are made on regular intervals, t equal to 1, 2, 3, and so on. And in many other real applications, like in healthcare, we also have irregular time series, for example, in electronic health records. And these are time series measured at irregular intervals. In terms of feature type, this describes the characteristic of each feature. For example, the feature can be continuous, integer, or categorical. And SinCity even supports censored feature as widely used in survival analysis. And in this case, we have a sensory indicator together with a survival time. So moving to composite data set, SinCity supports many different modalities of composite data sets. For example, it can be multiple static data sets collected from different sources or environments. We also allow for the combination of static and time series data set. For instance, in medical data, we have static demographic data together with some longitudinal follow-up data. So this is all well handled by SinCity module. And as we can see, it already covers the vast majority of dataset modality that we use day to day. Moving to the plugin, which is essentially the weightlifting part of SinCity, which contains a collection of different generative models. So the plugin module is designed to address diverse problem settings. And so far, we've talked about different use cases of synthetic data and different data modalities. And the combination of use cases and data modality creates a two-way table, where each cell, each being represents one specific problem setting. And for example, the green cell here maybe can represent generation of privacy-preserving static data. The purple cell might correspond to another setting where the requirement is to generate fair static data. The yellow cell might represent generation of censored data. And in each of these cells, SinCity provides at least one generative or sometimes multiple generative models as a plugin. And furthermore, the user can instantiate these generative models with different architectures. For instance, we noticed that in time series, for example, sometimes the observation frequency can be very high or very low, depending on the specific application. And for that, we have included, for example, the temporal convolutional neural network that excels at high frequency time series, and also more conventional recurrent neural networks that are also quite good at less frequent observations. And the secret sauce of building such a comprehensive list of models in relatively short development time in an extendable way is that we actually extracted and distilled the key novelty of previous research as building blocks. And we made sure through a re-implementation effort that these building blocks are interoperable with each other. So for example, the building block we're talking here can be, for example, a loss function or regularization term, a particular architecture, or a specific training procedure. And with these interoperable blocks, we can generate and create more quite easily new synthetic generators in the backend and make them to conform to the unified front end. So far, we've talked about a lot, talking about the training, problem setting and training models. But after the model is trained, we also need to evaluate the synthetic data. And SinCity also has a metric module that has a wide range of metrics to evaluate the various aspects of synthetic data, including fidelity, utility, and privacy. Fidelity usually refers to the closeness of synthetic data to real data. For example, how does the synthetic data look like real data? And for that, SinCity includes statistical divergence distance metrics like Wasserstein distance, maximum mean discrepancy, and many more. It also implements two-sample classifier tests, where a classifier tries to distinguish real from synthetic data. And in addition, it also has some novel metrics proposed in recent years that measures the fidelity. In terms of utility, it's really about how the synthetic data set is useful for a particular downstream task. And here we adopt the train on synthetic test on real regime, where we train an analytical model on the synthetic data and evaluate back on a holdout testing data set, which are real. And SinCity already also have many built-in analytical models to facilitate automated testing of utility. And last but not least, we also can evaluate privacy either using traditional metrics such as k-anonymity or L-diversity. And also we can evaluate privacy by a simulated privacy attack, for example, membership inference attack. So with all these three aspects, SinCity can be used as a holistic benchmark framework to really understand the quality and evaluate many aspects of synthetic data. So we hope SinCity become a valuable tool for both synthetic data research and application. For researchers, SinCity provides a playground for rapid experimentation and prototyping. it can be used as a one-stop shop for sort of benchmark if you are developing new generative models. And it provides an opportunity for extending research impact and translational research. Again, for practitioners, SinCity is a way to bring in cutting-edge research and democratize this technology, and also provides a unified solution to diverse problem sets. And SinCity is now available on GitHub together with a very detailed documentation on each of the user-facing APIs and the tutorial, which can be accessed either as Jupyter Notebook or on Colab. And you can find everything, all the useful links on our GitHub page. And we welcome you all to join our development effort and join our exciting community and contribute to these projects. And you can make contribution by creating a new issue on GitHub, for example, reporting bugs, requesting improvements, or adding new features, asking questions about technical topics. You can also open a pull request on GitHub, adding in plugins, especially perhaps the ones that are developed and published by yourself, and help resolve the existing issue. And all levels of experience are welcome, so please free to contribute, even if you do not have too much experience in open source software development. We are a very friendly and supportive community. So finally, we would like to talk about upcoming events, and we would like to very much invite you to join our vibrant community, which has already more than 100 members. And we're maintaining a mailing list to keep everyone updated and exchange of thoughts. So you can join the community by scanning this QR code or go to that link and fill out this form. The next upcoming event is actually the AAAI Lab that is going to happen next Wednesday on 8th of February. You can have get more information using that link. So unlike the conventional tutorials, this time we'll be running a hands-on session where you can get first-hand experience in generation and usage of synthetic data. The session will be run in a hybrid formula with a physical room in Washington, D.C., and also a virtual participation also allowed. And following the lab, we'll be running a quarterly community meetup to provide a venue for sharing progress and discussing future development plans. And we'll look much forward for your participation. Thank you.
Thank you so much, Zhaozhi. That was a fantastic presentation. I can see there's lots of interest already from the questions channel on Slack, and I look forward to taking many of those later on during the session after our panel discussion, which I am delighted to welcome a real tour de force of guests from a variety of industries. So if all of our panelists today could come on video now, I'm going to briefly introduce everybody, and then the floor will be turned over to Mihaela, who's going to be chairing today's panel discussion. So I'm delighted to be joined first by Elena Sizikova, who's a staff fellow at the Food and Drug Administration. We're also joined by Tucker Balch, a managing director from JP Morgan AI Research. Robert Tillman joins us as a research director in AI and machine learning from Optum Labs. We also have Nick Brown, who is the executive head of imaging and data analytics from AstraZeneca. From Accenture, we have Dimitrios Vlitas, who's an associate director of AI there. And finally, and but by no means least, we have Peter Krusche, who is a director of advanced methodology and data science from Novartis. So Mihaela, the floor is yours for our panel discussion today.
Thank you very much, Fergus, and thank you very much again to all the panelists for joining us. I'm going to start with a very simple question to you all. What challenges in your industry or your organization could synthetic data help and can help with? And maybe I'm going to start with you, Elena, who come more from a regulatory perspective and then move through the various industries.
Thank you, Mihaela, and I just wanted to thank everybody for organizing, Fergus, Tennyson, and others for organizing this amazing inspiration exchange. It's amazing to learn about the libraries and different ways we can use synthetic data. I wanted to preface that I'm new at the FDA. I'm a research scientist there, so I would more of my own opinion rather than a regulatory perspective. But I think there's this very cool things that synthetic data can do, digitally simulated data. But in particular, we can think about how it can be used for addressing clinical trial limitations, where it's not possible to sort of do test all of the cases we can in clinical trials. Can we actually use synthetic data to, for example, test different doses or look at different conditions, address difficulties in recruitment of diverse populations that are sufficiently representative to tackle, and look at rare diseases, again, cases which would be difficult to get real data for.
Thank you very much, Elena. Maybe Nick, would you like to go next?
Sure, no problem. Again, it was just fantastic to see, great tools like this being put into the public domain. Really second what Elena said. For those who don't know me, I'm Nick Brown. I head up the imaging data analytics AI team, CPSS and AstraZeneca. Essentially, in my world, we deal with a lot of preclinical discovery and clinical development data. It's really important that we make sure that drugs are safe as they go forward into man. And so for us, we're always dealing with a huge amount of data, from experimental screens, imaging, omics, to clinical trial patient level data. And actually, often we see the same sort of challenges across those different sources that we have to overcome. So there's probably 3 areas that we're sort of dabbling with and exploring for where synthetic data can help us. The first is really around missing experimental data. That really improves our models. But today we've probably got about 60 data sets where we've imputed using synthetic data. Being able to scramble by looking at random sampling of characteristics. And for us, that's really improved what we've seen with our AI models. The other thing is about images. So this is probably the second major area for us, where essentially what we've really tried to do is use it so that we can actually generate a huge number of synthetic images, which are really just slightly different from the original. It really represents the same object, different perspectives, and actually it'd be very difficult for us to go back and repeat that raw data collection. We've got over 100,000 examples of these sort of new images. And the last is probably looking at things like forecasting. So, in another role, we were looking at things like finance data. And so we generate 6,000 models a week to predict our marketed products in different areas. And actually to optimize those models, actually we'd have to start to consider different scenarios. So this is an example where you can't actually go and generate the data. It's future data and you can't predict some of the big things that could happen. But what you can do is you can start to simulate that. And actually using synthetic data, you can generate these kind of fake scenarios and then build really good predictive models for them. And then you can apply that into your modeling. And so that for us has been a really insightful way of actually improving our platforms and builds using synthetic data.
Thank you very much, Nick. Maybe I can go to Peter.
Yeah, thank
another
you.
Pharma company.
Thank you. It's very exciting to see kind of the development and open source tools and really useful stuff being put out there. So just some context on where I work in pharma. I work in the part of Novartis that's called global drug development. So our job is to essentially put drugs to the market through the approval process. And I think we arrived at synthetic data essentially through the perspective of privacy. So we want to do a secondary analysis on our clinical trial data. We can only do this if we sufficiently protect the privacy of the trial subjects. And existing approaches to that look at anonymization, which loses a lot of the data utility. So that's kind of where we came to look at synthetic data. But I think there's actually a lot of additional challenges that synthetic data can address. So one of them, for example, is just improvement in process. So if you think a lot of data science happens by directly going to the actual patient level data. And I think that's actually not a good way to go. So you can start with synthetic data, test your models and methods, and that applies to so many areas, from just data engineering to actual development of machine learning models. And then I think sort of on the more forward-looking end of things, I think also the ideas of, if you will, interpretable ML through conditional data generation, or looking at subgroups that are underrepresented in the input data. I think that's perhaps the bit in synthetic data I'm most excited about, but perhaps also the one that's the furthest out, I feel, in practice.
Thank you very much, Peter. Maybe to go a little bit further away now, Robert, would you like to go and talk a little bit about this?
Sure. So to give a little background as well, so Optum Labs is essentially the R&D part of United Health Group. And so one of the things that we're interested in is predicting disease progression using electronic healthcare records. And so I think one big challenge in this area is, even if you can access large data sets with millions of patients, sometimes when you're trying to study specific conditions, you may only have a very small set of samples that you can actually use. And that's because the data are often very sparse in terms of the features. And also there's many values that you may be interested in that are missing. So maybe you're interested in a condition that only occurs in a very small percentage of the population. So you have a very small set of samples to begin with. But when then you try and filter it down to those samples that still have the features that you're interested in for your analysis, you may be left with something that's very small. So imputation is very relevant, for this kind of task. But also, I think maybe a more challenging thing is if we could start thinking about, if you could develop a generative model that could learn from a very large population, but be able to generate for a lot of different, very specialized subpopulations, and also include the missing values that you may not have. And ideally, if you could do that without having to specify exactly what the definition is for all of these different subpopulations at training time, so that you could have this very general generative model that later on, when you have these specific tasks that come up, you would be able to generate from. So I think being able to generate in these lots of data but low data that's useful scenarios is something that we're very interested in.
Oh, wonderful. Thank you. Maybe now it's time to go to another industry altogether. So Dimitris, would you like to go next?
Yes, very happy to. So, okay, us as an Accenture, by definition, we call ourselves an horizontal, which means because we're consulting every industry. So essentially, we use synthetic in Accenture, we say it in 7 pillars, but it's exactly what the friends mentioned before. You're going to augment a weak signal, so there you go. You don't have enough data, you're going to augment data sources, fine. You're going to safely, because a lot of the companies, they use external vendors to allow them work on their data safely, there you go. Yeah, and digital twin, of course. Yeah, allow you to do safe simulations and so on and so forth. Yeah, and most importantly, which is, it's a very good approximation on one of the biggest questions in industry, which means sharing data across for the greater good between industries, between for various reasons, to get a 360 view because every industry sees certain demographic people or situation from a center point of view, if you like. So it can be extremely useful to do that. But above all, so essentially, whatever all the friends mentioned before, but one thing that we put a very big bet on us as an Accenture, which actually is the following thing, that because we think synthetic, exactly because, okay, so far in industry, I mean, an AI, again, I oversimplify here because when you talk so generally, you cannot avoid that. But you have AI has been treated as building a model that performs a certain task, which is great, no problem with that. But we really believe that the very next natural step is going from the tree to the forest, meaning from one model to a bunch of models that may interact with each other, and you can optimize them all together, and which can be reinforcement and can be other things, which we really believe there that synthetic can play an extremely important role in making data accessible in various shapes and forms, to be frank, yeah? And seeing the magnificent results of DeepMind by using synthetic, that they were able to do all these things that they did, yeah? And actually pushing forward in industry the impact of AI by creating ecosystems of things, and with synthetic is going, we think, to play a very, very important role, yeah?
Thank you. Dimitris, in view of time, sorry, I'm going to go to the next person. Just so we have more rounds of questions.
Of course.
Thank you very much. Tucker?
Hey there. I'm Tucker Balch. I'm a managing director at JP Morgan, of course, a financial institution. Just before joining JP Morgan, I was a professor at Georgia Tech, so I still have a little bit of academic smell on me, as the case may be. Anyhow, I want to say just a couple things. I appreciate the presentations earlier. Now, with regard to our challenges in the finance industry, of course, we deal with customer data, which has sensitivities with regard to privacy. We have market data, time series, but even finer grained than that, like orders that go into the exchanges and so on. Feedback on advertising campaigns, just lots and lots. I mean, the company is built of data. And so we have applications across all those sorts of data. I wanted to recap. I liked the presentation, which talked about metrics, and we've adopted the same list of metrics. Namely, I use the term realism as opposed to fidelity, but realism, privacy, and effectiveness. I think those are key. But I want to say realism is overrated. And in the following sense, there's a big thing in the finance industry. You test trading algorithms against historical market data. Well, if that's all you tested against, you're not going to be prepared for things that haven't happened in history. So I would like to see us focus additional light on generative models that can create things that have never come before. In our case, we do that with market simulations, but I know there's many other ways to do that. Now, this first question was, what challenges can synthetic data address in my industry? I just wanted to mention two important ones. Sensitivity of data. If we can take a data set and step down the sensitivity and just share it. We can't even share data within our company, much less externally, because of these concerns. If we could step down the sensitivity, that helps a lot. And another is testing, and particularly in testing. In other words, we've got a trading algorithm. How does it work in a stressful market, or flash up or flash down? And we only have a few examples of those in history. And this is, again, a situation where realism doesn't matter so much. We just want to make sure that our algorithm doesn't implode or break. But anyways, thanks. That's my.
Thank you very much. Very insightful. I'm going now to move to another question, which is, what do you think is the biggest hurdle to using synthetic data? And some of you have already mentioned that, but some of you have not. An accompanying question, what are the major unaddressed challenges? And given the fact that we would like to go through more questions, I want to ask all of you, the panelists, to give a 1-minute answer if you can. Robert, maybe I start with you.
Yeah, sure. So I actually think the biggest challenge is maybe non-technical, which is just convincing stakeholders that it's okay to use synthetic data, and that the real data is actually, or the synthetic data is representative of the real data. And I think it can be challenging for both technical and non-technical stakeholders. So one thing, we do have all these metrics that we can look at, but a question sometimes from someone who's not consuming this all the time is, okay, which one should we care about, or what's a gold standard? So if we pass these metrics, it's okay to use synthetic data. So that's maybe something to consider with technical stakeholders, but then with non-technical stakeholders who may not even be able to understand the metrics, how can we think about visualizing, real versus synthetic data in a way that is intuitively clear? And that could be easy with something like images, but if you're thinking about tabular data, time series, it's not obvious how to convince someone that this data is, realistic and it's private. So coming up with better ways to do those is, I think, a big challenge.
Thank you. Peter?
All right. So I guess as a scientist, I think anything I say about practical challenges should probably taken with a grain of salt, but I think the main practical challenge, I agree, is convincing non-technical stakeholders that this is real and this can be used. And by non-technical, we could mean clinicians, for example, or we could also mean a privacy department to say that actually this data, the synthetic data, doesn't reveal any information about patients. I think standardizing metrics is perhaps a first step, but maybe not the only. I think there's also scientific challenges if you think about multimodal synthetic data, where I think really understanding how correlations between modalities are preserved in models is something I think that isn't necessarily captured directly in most metrics we compute at the moment. So that would be my 1 minute.
Thank you very much. Tucker?
Hi, everybody stole what I was going to say. So anyways, but let me hone in on one specific example that we encountered recently. The question arises, especially with using synthetic data for augmentation, the question arises, well, we have this real data. There's information in that real data. Why don't we just improve? And by the way, the reason we're arguing for the synthetic data is the models that are learned from it aren't necessarily effective, and we can make the models better. Well, there's a question of, well, why don't we spend time making the model learning better? What's it missing? Why do we need the synthetic data? Anyways, as a sort of field, if synthetic data is a field, I think that's a fundamental question we need to have a good answer for. And I'll tell you mine later.
Nick?
Sure. I think everyone's suggested a similar sort of thing. So I'll stick on the same theme. And, as it's probably around that confidence and trust, management have bought into data, they've bought into AI. But in large companies, we have an enormous amount of data we just can't handle. And so actually, I think we have to help them to understand why we want to build even more synthetic data to then use, not just handle the data that we've already got. How are we going to handle things in the future how do we label our data so we know what was real and actually what was synthetic? And so you really need to think about that from the beginning as we start to do this with, our information management systems. A second piece I would also say is that I think there's an awful lot of work that's been done on partial synthetic. I think, there's about 100 startup companies that are in that space for imputing, but there's very few that are really focusing on things like full synthetic. And so again, I think that's an interesting area in the future that hasn't really been addressed.
Thank you very much. Dimitrios?
For me, I would be bold and I would say, if we can convince them with mathematical metrics, that synthetic, they're close to original and they solve major privacy things, then it's going to be good enough. You know what I mean? Then I think life is going to go on and it's going to converge to the right place.
We can still smell you have been an academic not too long ago, Dimitrios.
Exactly.
Elena?
I think that it is, so different industries have different requirements for synthetic data. And so I think making synthetic data that is useful in that specific industry or field is important. In healthcare and sort of field I work, it's important that this data is realistic. And in general, evaluating synthetic data, coming up with metrics, and particularly studying the limitations of it. So what can and cannot do, so being very specific about that is very important. understanding sort of what kind of biases it can introduce if we go sort of half synthetic or fully synthetic route. And finally, making generators for synthetic data. So things like SinCity and others, making sure that sort of people can use these generators widely and test their models on them.
Thank you very much. Let me now move more directly to this package that we have released, and we realize that this is recent and you may not have had time to really take a look at it. But I want to ask all of you, the panelists, what features or functionality of SinCity do you like most? And at the same time, what additional features would you like to see included or improved in the future? I don't know who wants to start.
I have a go. Mihaela, it seems to me, but maybe I missed it from the slides, not I haven't played with that. That is more, it's very GAN-based thing, or there are other machines too?
That is not, there are numerous methods, numerous machine learning methods. Zhaozhi, would you like to give us a brief summary of what other things besides GAN, very briefly?
Yeah. So we have both deep generative models like GANs, VAEs, normalizing flows, as well as like more traditional Bayesian network type of models, and we're also planning to put in CoPlus in the future. So
then you cover everything there is. Okay, then no comment.
And we hope that the community, as Zhaozhi has mentioned, will help further build this into the future. Anyone else that may have had time to look at it?
I'm happy to go next. So for us, I think one of the biggest things is probably some of the work that you've got in there around fairness, actually. So actually, one of the things that we've done at AstraZeneca is spend quite a lot of time to think about the sustainability of AI for us, and actually put forward quite a strong proposal around the ethics around using AI in our company. So actually, I think having tools like this that actually allow us to start to think about not just our AI, but our data, and how we make sure we have, fair data, how we have no bias in those data sets is critical. Putting privacy at the core of that is great. Thinking about additional features, I'm trying to think where this goes next. And I think one of the two pieces that come to mind, the first is that actually you talk a lot about benchmarks. And I think running that through PIP's fantastic. But actually, how could we do something, or where does this lead, where you can actually start to have some of those benchmarks that become a bit more public? You can then start to work out for certain data types, these sort of approaches are actually better than others. Other things that can be more public in that sort of space. And maybe stretching that a bit further is, could you even go as far and bold as to actually have gold data sets that you actually have taken from different industries, created synthetically and made available to people? It goes back to the point we just raised at the last question. I think if people start to see examples of data sets from different industries where it was confidential, it was sensitive, it was private, but it's been made available and people can access this and use it in AI, we're all crying out for those kind of data sets. But suddenly you start to recognize that actually this is the power of what those synthetic data sets could be. So I actually see this as a way of kind of leapfrogging to be able to say, could you then have kind of places where people could see that sort of information?
Wonderful. I don't know if anyone else, Peter or Dimitrios or Tucker or Elena.
I can say something. I do apologize. I don't know yet the details of the platform, but first of all, I think it's a great contribution to build something and share something like that. A way that I would anticipate our group leveraging it is, if there are multiple methods implemented for generating similar types of data, which I'm sure there are, it provides a really nice way of comparing the underlying algorithms, and their appropriateness to different types of data. One thing we've discovered is certain approaches work better for certain types of data. One other, with regard to feature that I would like to see, I think, so in particular, if we have a synthetic data set and a real data set, there's a number of different ways that we could analyze and compare them. Well, I said earlier, realism is overrated, but a measure of fidelity would be a good one. A measure of privacy. Maybe it's hard to measure effectiveness. I don't know. But anyways, tools that can take those two sets of data and assess them in that way, I think would be very nice.
And some of them are there already. Zhaozhi, would you like to say a few words just briefly about that? Because I think Tucker mentioned important points, and I think some of them are addressed, some of them are not. But can you say a few things?
Yeah, for privacy, we did have some of the metrics already there, and we are also have planned to add more metrics, more types of simulated attacks, and so on. Yeah,
and also on fidelity and accuracy.
Do you have any plan? Sorry.
Excuse me, Elena.
Oh, I was going to ask, it might be helpful also if you are considering to include image data.
Definitely. And we hope that as a community, we will build for many modalities such a platform. Again, this is why we hope to reach out to the broader community. Anyone else? I don't know, Peter, I don't want to put you on the spot.
Yeah, so two thoughts. So I actually took the time I took for preparing for this also to try out the package. So I played around with it a bit. I think the thing I would say I like about it most is that I got it to work within that amount of time, which is great. So that I think shows that even me can make it work, so to say, in a little bit amount of time. That's probably a great start to really empowering the community to doing something with it. I also like that you can sort of have an easy transition from existing tools like SDV. You show an example how to make CT-GAN work, for example, which I also liked. I think in terms of features, I guess more features maybe is not necessary, but be looking for what rather kind of a path through the library that really would lead to something end-to-end that would work in line with what others have said before. I think you need to give people a way to choose the right tool, the right metric, and the right model. And maybe build a library really of that around this. I think that would really then also help realize the potential of what you've built here.
Brilliant. Yeah. Fantastic food for thought from all of you. In view of time, I'm going to thank all of you, the panelists, for all the insights and for the participation and for giving us so much food for thought. And maybe I will let now Fergus open the floor to questions to both Zhaozhi as well as the panel. So Fergus, floor is yours. But thank you once more time, all of you, for joining us, the panelists.
Thanks, Mihaela, and I just want to echo those thanks to everybody. That was super fascinating. I think there'll be lots of questions that hopefully we've got some time to take some of them. I want to start with a question from Sundog Kim. So the format for this Q&A session, if I call on you, if you could just kind of come on video if you're able, unmute yourself, and then ask your question as succinctly as possible, and then we'll try and answer as many as we've got time for. So Sundong, do you want to ask your question? I think it's for Zhaozhi about the SinCity package.
Right. So we have been developed and released the publicly available synthetic data set for customs community, and we have presented them in World Customs Organization. And I would like to somehow promote this and also like to contribute this to the Synthcity package. We have used like some simple binding technique, but can be useful on top of the CT-GAN. So what would be the best way for us to contribute to the project?
Yeah, definitely. So I think the first step is maybe you can create an issue on SinCity and list give a bit more information about the model you're using, the prior publications, and then after the issue is created, and you can go on and try to build your own kind of adaptation of CT-GAN and try to integrate it in the SinCity package. And after you raise the pull request, we will review it and merge it into the main SinCity package. Yeah.
Got it. We'll have a look. So if there are any initiatives working with a public sector, just let us know. I can bridge you to the customs community. Thank you.
Thank you.
Thank you so much. I think the next question we're going to take live during the session is from Narasimha. If you could unmute yourself and ask your question. I think you had a few questions. Maybe if you could just pick one of those questions to ask.
Yeah. Hi.
Okay, great. Fantastic.
Yeah, I think I'm sorry, due to bandwidth issues, I cannot turn on my video, but I can just speak. I hope you can hear me loud and clear.
Yep, we can hear you just fine.
Yeah, great. So yeah, my question is, do we have any testing toolkits to test the validity of the metadata and the input data before we feed it to the Synthcity library? Like, do you have any
Yes.
testing?
Yes. So in the data loader, in the data loader module, the user can actually supply 3 different types of metadata, and one particular one of relevance is, for example, the description of each feature. For example, the type of feature and the constraints. So, for instance, we expect a certain feature to be only take value from one range, and we can enforce that even before and after. Before training and also even after the generation, we can enforce these type of constraints.
Just a quick follow-up question. Can you also mention the dependency between the variables as part of the metadata? Like if you know that, let's say feature 1 and feature 5 are dependent on each other, like if you already know the dependency relationships, would it be possible to provide that in the metadata format?
Yeah, this is, I think this is specific to some of the algorithms. So in SinCity, we already have some algorithm that uses data based on causal deep learning, and you can actually input a causal graph or dependency graph for this type of algorithm. So yes.
Okay, yeah, thanks.
Thank you.
Fantastic. Thank you for your question. I think we're going to change tacks a little bit. I'm going to take a question for our panelists from Enrique. So I see you had a couple of questions. Maybe you could just pick one of the 2 in the interest of time. If you have any particular panelist or industry you want to focus this on, please say as well. And then maybe we'll get the opinion of 1 or 2 of our panelists who want to jump in on this. I think the video mic is not working. So I think the question is, how do you see the evolution of AI/ML in industrial applications? More specifically, how do you foresee the development of intra-company research data science labs compared with outsourcing these technical qualifications, e.g. for AI and ML consultancies? So maybe this is fun if we have someone from one of the kind of in-house companies, and then maybe we get a competing viewpoint from Dimitrios as well. I don't know who wants to jump in first on this.
I don't mind. I used to run an AI engineering group in AZ, which was about 100 strong. Over the last few years, AstraZeneca's recruited about 650, 700 data scientists and AI engineers into the organization. So, as a very data-rich company, we see having the ability to be able to analyze our data as really key and at the heart of what we do. I think, over time, we're going to see a change. We're going to start to see AI much more embedded in everything that we do. We're seeing this, obviously with some of the generative AI things that are taking place now. I will say that, as I alluded to before around, management bought into data and they've bought into AI. I think what we've seen our execs start to then say, well, how can we apply that in different areas? So we started very heavily in R&D. We're now starting to see that in areas like operations. And what tends to happen is they tend to jump straight to the consultants to be able to go, hey, let's go and do some POCs. And I think then the sort of reality sets in is that actually, if you really want to embed this, it has to be part of your workflow. It has to be something that you can industrialize and you can make into something that is every day. And that is a combination of in-house and outside resource. It has to be a combination. But I think probably the biggest bit is that there's a realization that it's not just a silver bullet that you buy a tool off the shelf. You know, it's about how do you do science? How do you look at the latest and greatest research, bring it in and customize that, and then scale it out. And that's a really tough thing to do.
Thanks, Nick. I think that's a super interesting perspective on this, and crazy to hear how much this has obviously grown in companies such as yours over the last few years. Dimitrios, I don't know if you had anything you wanted to add to that, especially from the different viewpoint.
Yes, absolutely. So to my personal opinion here, I don't know if I represent Accenture here or not, in this thing is, given that everyone, meaning the big players, they move into the cloud, which in my opinion, mostly cloud gives you all the prerequisites to do AI, really. Yeah, because the main benefit, I would say, okay? So I really expect that, which means a bigger obstacle was a lot of legacy system and people they wanted, but they didn't have the technology on-prem, blah, 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 you know, all that drama that eventually disappearing, yeah? So you need academia always is going to bring the formidable ideas, and it's going to show the North Star and so on and so forth, and it's going to provide, I mean, not only from research, provide manpower and talent to the industry, you know, from education and all that. So you guys as an academics, you play a very, very, very important role in various, from shown in the North Star and what creating breakthroughs, and then supplying intelligence. And given that cloud and the hardware, it gets up to speed to address the demand. So I expect to see, you know, a great boost, whatever I mentioned before, going from the tree to the forest, creating more intelligent and more intelligent and more intelligent system, and obviously both for data and then from modeling data for the greater good. Yeah, I stop here in the interest of time.
Fantastic. Thank you so much for that. I think our next question is from Mathieu. Do you want to unmute yourself and ask your question?
Yeah, sure. My question was about the rest of the ecosystem, because the SDV library, and I was wondering why making a new one instead of contributing to SDV, for instance.
Yeah, thanks for raising this question. I think I need to share the screen again and point to you to some additional resources. So here is the GitHub repository of SinCity, and we also have composed a white paper that come out together with the library, and it's on archive. And on this paper, we have a very detailed comparison with all the existing softwares that can generate synthetic data. And this includes SDV, as we know, and also many more, like Y-Data, Gretel, and so on. And by far, SinCity is the one that has the widest selection of models, generators, and also covers the broadest problem settings in terms of different data modalities, in terms of the problem settings and use cases. And the reason we start SinCity is because we believe that in order to enable such wide range of problem settings, we need to re-implement the current building block. And this is the building block story we gave. And also, in addition, we also, so if you can find, we can also find more detailed comparisons on the list of evaluation metrics, as well as the availability of models. For SDV in particular, we have also used an SDV before, but we found that it mainly implements the CT-GAN model, and it has currently at least some limited support for privacy preserving methods, and also the support for time series is also just starting. Hope that answered your question. Thank you.
Great, thank you. Thank you for answering that, Zhaozhi. Our next question is going to be from Dennis, who I think has some questions about hyperparameters.
Yes, Hi everyone. I just had a question regarding how the hyperparameter tuning is handled in the package. So I haven't read the paper, so maybe address this question there. But also, like both regarding the models that you use to generate the synthetic data and the models that you use to evaluate the data.
Yeah. For the hyperparameter, so we've ensured that SinCity is compatible with external tools for hyperparameter optimization. And by that, I mean that each generator has a predefined hyperparameter space. It's kind of a method of the generator. So it can return you the space of hyperparameter space. And what you need to do is to define the metric that you care about and pass the space of hyperparameter to an external kind of hyperparameter optimization routine of your choice. For example, you can use Bayesian optimization or whatnot. And that will basically solve the hyperparameter tuning part. And in addition, I also want to mention that SinCity also has enabled early stopping because how many iterations you should train a GAN or some generative model is a very hard problem. So in SinCity, you can select a list of metrics of your choice. So for example, if you really don't care too much about fidelity or realism, you can put more attention on like privacy, select that as a metric. And during training, the early stopping module will look at the metric of your choice and see if it keeps, and it will stop the training process automatically if the metric hasn't improved for a while.
Great, thanks a lot.
Thank you.
Thanks for the great question, Dennis. Hyperparameters are always a tricky one, especially for generative models. I think in the interest of time, we've got enough time for one final question from Severin. If you wanted to unmute yourself and ask one of your questions. Hello.
Hi. So I was actually asking 3 questions, but I can be quick and pick one. Yeah, so now I guess you've had a lot of inspiring inputs about this already, but I'm curious about what will be your focus in further developing the package. What kind of features will you focus on, maybe except for the imputation methods that you describe in your paper, and how will you manage package maintenance in the long run? So what I'm interested in here is how you see this package evolve over time.
Yeah, great question. So I think over the time, we'll collect a wider variety of models for different use cases. Because, for instance, for now, and some of the problem settings is actually still open research area. For example, how to issue privacy preserving data for time series is still pretty much an ongoing research area. And would like to see more of the models being implemented and being supported. And so we can start to really to run benchmark studies and understand which type of model really performs in which type of scenario. And I think going forward is more about increasing the breadth of coverage of different types of models and also to conquer even harder problem settings. Thank you.
As well as data modalities.
Fantastic. Thank you for your questions, Everin. And apologies we didn't have time to get through all of the questions. For anyone who's posted in Slack, we will try and answer any of the questions we didn't take in Slack and maybe point people in the right direction for some of their questions. So just before we close, I would like to thank our panelists and speaker Zhaozhi once again. It was a fantastic session today. I hope you guys all enjoyed it as much as I did. The session will be on YouTube soon. If you have colleagues that missed today's session that you think would find it interesting and insightful to hear from all of today's speakers. And finally, I want to advertise our next session, which will be taking place later this month on the 28th of February. The topic of causal deep learning. This is a new emerging area that's moving very rapidly. So I'm delighted that we are getting a chance to revisit this topic in Inspiration Exchange and discuss all of the new developments. In the meantime, thank you everybody for joining today. and hopefully see you in a few weeks' time for our next session. Thank you very much.